Hello, so today we are going to take a look at this problem, which is part of Leetcode Weekly Contest 333, this week's contest. So the problem is merge two 2D arrays by summing values. So what we have here is two integer arrays. Each of them is two-dimensional, so nums1 and nums2, and each value of each one contains an ID and a value. Okay, and that basically indicates that the number with the ID, that ID has a value of val, right? So the number of this ID has a value of val. Okay, so that's what the input that we have, and we are told that each of these contains unique IDs, right? And is also sorted in ascending order by ID. So nums1 is sorted in ascending order by ID, and nums2 is sorted in ascending order by ID as well, right? And what we want to do is merge the two arrays into one array that is also sorted. So both of them are sorted and we want to return it sorted, with the condition that only IDs that appear in at least one of the two arrays should be included in the resulting array. So basically we only merge, this sort of is evident because we only merge the two arrays, and so only IDs from one or the other needs to be in the result. And each ID will be included once. So basically, if the ID appears both in nums1 and nums2, we want to take the sum of the values and assign them to that ID in the result array. Okay, so and the result array needs to be sorted in ascending order by ID, similar to both arrays as well. So for example, with this input nums1 and nums2, 1 appears two times, right? It appears here and here, so we need to sum 2 and 4. And so ID1 has value 6. 2 appears only here, so it still has value 3. 3 appears only here, so it has value of 2. The same value here. 4 appears both here and here, so we need to sum 5 and 1, so that's 6. That's what we have here. And here you can see this is sorted by ID because we have 1, 2, 3, 4, right? So that's what the problem asks us to do. Now, we can definitely, the easiest way to do this is just take a map, right, from ID to a value, and just go through nums1 first, and each time assign the ID equal and add the val for that ID, right? And then at the end just sort the array. So that's the simplest solution. Let's code it up, but that solution doesn't take advantage of the fact that the two arrays are sorted. So after we do that solution, we'll evolve to a solution that takes advantage of the sorted nature of the two arrays, right? So for that solution, we just have a map, right? And we go through the values in nums1 first, right? And we just take the ID and we add val, right? And then we do the same thing for nums. And so if the ID appears twice in both arrays, we'll just add the values together. If it appears only in one, we'll just set it. And here, because we are using default of int, the value initially will be 0, okay? And now we'll just create a result array, because remember, the result needs to be an array of ID and value in a list and not a map, right? So we need to just convert this map to a list. And so we'll just go through the items in the map, and then each of them will just add it to the result, right? And so that would be something like this. Okay, so we'll just go through the ID and the value in the values map, and then we just add them to the list. And then we need to sort the array so that we can get it in sorted order by ID, and that's what this will do. And we'll just return it. Okay, so this one should work fine, right? In terms of time complexity, we are doing O of n1 here, n1 being the length of nums1, and n2 being the length of nums2. So if we do that, then it's going to be O of n1 plus n2. And then this here is going to also be the number of values. The number of values can be up to the sum of the two as well. And so it's going to be n1 plus n2. So let's multiply it. So multiplied by those two. And this sorting here is O of n log n. Res is up to also n1 plus n2. So it's going to be plus. This is sorting here is O of n log n. So it's going to be n plus 1 log of n plus 1, right? And so roughly we can just, this is the highest value, and so we just use that, and so it's going to be this. in terms of time. In terms of space, we are using this extra values map, right? And this list here, so it's going to be O of n1 plus n2 space. Okay. So that's the time complexity, but can we do better? Because the two lists are sorted, right? nums1 and nums2 is sorted, and the result that we want needs to be also sorted by ID. So this does look like just the merge portion of merge sort, right? So we can do exactly that. So instead of creating a map, we'll just have our list, and as we go, we will merge them in the proper order. So how do we do that? So we have our result array first, and we need two indices, one for each position, right? And then we need just to keep track of the length of each array. So this will just make it simpler. Okay. And now what we want to do is, while we still have values in both, right? What we'll do is something like this. So let me show you what we'll do here in the example. So let's take this one. So this is nums1, nums2. So what we'll do basically initially is I is here, right? And j is here. So we want to compare the IDs, right? Okay, so if the IDs are equal, what should we do? If the IDs are equal, then it doesn't matter. Then we just need to, so this is our res. So in this case, since the IDs are equal, we want to have the IDs still the same, but we want to sum up the elements. So we need to have 6. And what helps here is that the problem says that each array contains unique IDs. So there is no case where we would have here 1, 3, for example. That won't happen. Or here as well, 1, 3 or something. That won't happen because, so we are guaranteed that if we do this, that's going to be the only ID for that one. Okay. And so in this case, if they are equal, we want to just say, so what I did here is basically just took the nums1, right? Nums1 at position 0, that's the ID, that's 1. We just put that here, right? And then the value is going to be just the sum. So it's going to be nums1 at I, right? And this is going to be nums1 at I. We take the value and we do the same thing for j. J is going to be the index in nums2, and we take the value. So this is what we are going to add to the result, right? So the ID is just the one in the first index, and the value is going to be just the sum, right? So that's what we'll do here. So here let's actually call them ij, like we did in this example. So this is going to be I, and this is j is going to be the index in nums2. And so here we are going to check if the IDs are the same. That's what we did in this first case. So if the IDs are the same, so nums1 I in position 0, that's the ID. If that's equal to nums2 in position j, because that's a position for nums2, so this means that the IDs are equal. So we just need to add this to our result, right? So just append this, okay? And we need to move both indices because we handled both in this case, right? So that's what we do here. So we need to increase both indices. Okay, now otherwise, we want to maintain the order of the IDs, right? So we want to pick the smallest one and add that one to the result and then move I. Because 2 is smaller than 3, we want to move I, okay? So if the ID in nums1 is smaller than the ID in nums2, right? Then we want to move I, but we also want to add just this here, 2, 3, right? So in this case, we just want to add 2, 3. What is 2, 3? 2, 3 is just nums1 at position I, right? And we want to increment I in this case. So that should be it there. Now, otherwise, that means that we are in this case. So here 4 is bigger, so this 3 is bigger. That means we want to add this to the result and move j here, right? So that's exactly what we are going to do. Then we are going to just nums2 at j. It's the one that we want to add because that's the smaller one. And then we want to increment to j. Okay? Now when we exit, let's say in this case here we'll go here and just add. But let's say we had another thing like 6, n2 here. So we'll exit here because now j is equal to n2. So we'll exit because we will increment here. But we want to make sure we add this one. So basically, in that case, we want to check if I is still smaller than n1, because maybe we exited because j is the one that exceeded n2, that reached n2. So in that case, what do we want to do? Well, we just want to add the value itself, right? And so we just say res. We do the same thing like we did here. And we increment I plus 1. So this is exactly like merge part of merge sort. Okay. This is just merging two sorted arrays, except here it's slightly complicated because of the ID part. And now we want to do the same thing, because what if this actually was here in nums2 and not in nums1, right? Then we want to do the same thing and add here. So we want to check while j is smaller than n2, because we might have exited because I is equal to n, reached the end of nums1, right? And so in this case, we want to do similar to this here, right? Okay, and that should be it. And then at the end, we can return res. Okay, so let's try it. Nums1 I. Okay, so we need actually to have nums2 here. Sorry about that. So let's run this, because the n2 needs to be the length of nums2 array. So if we submit, this passes. Now, in terms of time complexity, is this better? So this loop here is O of the, at most, is O of the min, right? Whichever is smaller is going to end first. Now with this here is O of n1. Okay. And this here is O of n2. So overall it's just the sum of these, right? So it's O of min of one of them, n1 plus n2. So at most it's just O of n1 plus n2. So this is the time. So you see it's a lot better than what we had previously with the log. In terms of space, we are not using any extra. We are just using the list, which we'll have to use, right, to be able to return the merged list, because we don't do this in place. And so it's still unfortunately of n1 plus n2 space, but the time is better. Yeah, so that's pretty much it for this problem. This solution is a lot better than the just normal one, the previous one, because this one takes advantage of the fact that nums1 and nums2 are sorted and have unique IDs. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.